ASTRO Energy is, of course, one of the most important and leading companies in the solar industry. And right now, the company is promoting its ASTRO N7 66 cell product, and also it is promoting its ASTRO N7 ZBB-TF TOPCon products. It is clear that the company continues focus on the efficiency and in the leading in the industry. And right now, I'm not gonna talk about the company's new products. I'm gonna talk about these products, but with one of the most important people in this company. I'm talking with Jack Zhou. He's head of Astronergy Global Product Management. Jack, thank you for being here today. It's a pleasure for us to talk with you today.
Hi, nice to meet you.
Thank you. Thank you for being here today with us, Jack. And I have some specific questions for you about these two new products, but I want to start talking about the ASTRO N7 66 cell product. How do you think this new technology advances in the products and will meet the changing demands of the large-scale solar market?
Okay, for this question, I need to say that this N7 product is specially designed for the utility scale application. You know, for the end user of the utility scale projects, what do they care about? Most care about is LCOE. So, firstly, I need to say that before we design this module, we take every aspect together to consider this point. You know, in N7, we successfully introduced a rectangular wafer. And why we wanted to use a rectangular wafer? Because we wanted to take the ingot manufacturing process, the solar wafer slicing process, solar cell manufacturing process, solar module assembly process, and even the transportation process, and take all aspects together to analyze which is the design boundary of the module. And finally, we see that if we use the rectangular wafer, we can not only reduce cost during different manufacturing process, but also to reduce BOS and LCOE from the end user viewpoint. So that's why we wanted to have N7. And secondly is that we wanted to find a balance between high current and high voltage. I will explain for you. You know, right now in the whole industry, if we wanted to have a module, the power higher than 600 watts, there are two solutions. First solution is we use 210 by 210 square wafer 66 cells design. But this solution, the current is a little bigger, maybe 18.5 and 19 amperes. And the current is a little bigger, you know. So, and there also really exist some risks during the transportation, during installation, and how to say, the unpacking, you know. So this is the first point, the high current. The second solution is we can use 182 by 182 square wafer to design a 78 cells module. And it can also attain 600 watt power class, but as a voltage is a little higher. So the quantity in one string cannot be as big as before. So the BOS cost cannot be reduced very deeply. So we wanted to find a balance between these two solutions. So that's why we designed the ASTRO N7. We use 182 by 210 square wafer and put this wafer, use 66 cells. And we can find it. So this module is, the size is moderate and the power is also very competitive. Okay, this is, I explained why we wanted to have N7. And secondly, I think for your question, I need to explain the N7 has some key features. For example, it has very high power. The power can up to 615 watts. And secondly, N7 has a much higher module efficiency, around 22.8%. Thirdly, we use N-TOPCon technology, and it has much higher power generation per watt compared with conventional modules. And the fourth one is we successfully introduced many leading edge technologies like super multi-bus bar, like high transparent glass to improve the reliability. And last but not least is the LCOE is much lower than before. So that's why N7 has many technological advance to face the larger scale, solar market.
You already mentioned the efficiency, and I want to go deeper in this specific point, asking you, what do you think are the specific benefits of greater than 615 watts output power and the 22.8% efficiency in terms of performance and energy output compared of these conventional products?
Okay, I think to answer this question, I can divide it into two aspects. First, let me compare with the traditional P-type module. So compare with the P-type PERC module, ASTRO N7 use the N-type TOPCon solar cell. So N7 absolutely has all the N-type TOPCon key features. For example, the bifacial rate is a little higher than P-type, and the lower operation temperature, the much higher low irradiance performance, and lower LID and AETID. So N7 absolutely will have much higher power generation compared with traditional P-type modules. So the power is also a little higher. The module efficiency will attain 22.8. And second, let's compare with the traditional N-type square wafer modules. For example, like I think the 182 by 182, 72 cells. I think the corresponding mainstream power is around 575 watts. So compare with this N-type module, our N7 has additional at least 3 watts higher than before. So you can see the module size keep the same. I mean, the width of the module still keeps 1134, but every module's power has raised to higher than 600. So of course, the BOS will be reduced, and the LCOE, of course, will be reduced. And thirdly, N7 with the VOC of the module will be a little lower. So it means in one string, you can connect additional 2 modules compared with before. So so from this viewpoint, in one string, you will have more string power. And in one checker, you will be 3 strings. So in one checker, you will have additional 6 additional modules. So the checker power will also be higher than before. So that's why this module is very outstanding compared with conventional modules. Okay.
And let's move forward to this second product and talking about the ASTRO N7s ZBB-TF TOPCon models. I want to ask you, could you explain in detail the main factors contributing of this 23% efficiency and more than 460 watts output of this product?
Okay, for N7S, I think it's a very good topic because I'm very proud of this product because power, the appearance, and even the module efficiency is much higher than our competitors' products. Actually, we introduced many latest technologies. First, we use 191.6 rectangular wafer. In the industries, there are many rectangular wafer size. For example, like 182 by 188, 182 by 186. But here we use 191.6. So from this viewpoint, our wafer size is bigger than other competitors' products. Secondly, we use the negative gap process. It means we remove the gaps between every two cells. So we can make a full use of the area of the module. So means we will have much higher solar cell density in the limited area of the module. So of course, the module efficiency will be improved. And thirdly, we successfully introduced zero busbar and a tandem field. In zero busbar, we will remove the pad points during the screen printing process, and by this way to reduce the light shading, and the solar cell efficiency will be improved. And we use a tandem film to ensure the negative gap has much higher yield to prevent the crack rate be higher than before. So with these technologies, we ensure that our N7S can attain 23% solar module efficiency and 460 watt module power. Okay.
And let's put together these two products. And putting together these two new products, how do you think these benefit the residential users in terms of size, efficiency, and of course cost?
Okay. For N7S, actually, before we design the module, we already do investigations, and we find that in Europe, especially in Germany, there really has policies that all the modules installed on the rooftop of the house should be controlled within 2 square meters. So for N7S, when we do the design, we try to fix the module size controlled within 2 square meters. And so, and the weight of the module will control within around 21.5 kilogram. So it's very easy for one people to hold it, to operate it. So from this viewpoint, our products can successfully face the Europe residential application demands. And for the appearance and the efficiency and the cost, I think the efficiency, you can see we successfully introduced many technologies. And N7, our efficiency can attain 22.8, and 7S, we have 23% module efficiency. I think compared with other competitors' products, our power, our module efficiency is very competitive. And for the cost, you can see we use a rectangular wafer. As I have said, that use rectangle reduced the different manufacturing process cost. And here we also successfully used the zero busbar. You know, zero busbar is a very leading edge technology because we improve the solar cell efficiency, and also there will be no soldering process. No soldering process means all the contact between the ribbon and the solar cell will be finished during the lamination process. So it's more environmental and the cost potential, high cost potential, because we can control the wafer thickness more thinner than before. So from this viewpoint, the cost we have more cost potential, cost effective for these two products. Okay.
And I wanted to ask you about this CCB technology. How do you think it contributed to lower production costs and improve aesthetic PV models?
for this question, I think I want to answer for two aspects. First, for the cost down aspects, as I have said, that you use if we use zero bus bar, there will be no pad points. So the silver paste can be reduced. So it means the cost can be reduced during the solar cell process. The secondly, the shading of the light can be reduced because we use zero bus bar, there's no pad points, so the efficiency can be improved. So efficiency be improved, of course, the corresponding the cost of the solar cell be reduced. The third point is there's no soldering process during the module assembly factory. So the process is more environmental. You know, during the soldering process, the temperature is a little higher than the lamination process. So compare with before, it's the electricity consumption during the module assembly process will be lower than before. And the fourth one is there's no soldering process, means we don't need to use the how to say the ribbon size. I mean the ribbon diameter can be controlled more small than before. So the ribbon cost, so wafer thickness can be reduced. As you know, for the module, the carbon footprint, mainly carbon footprint exists in the wafer. If we can reduce the wafer thickness, it will be a very good contribution to reduce the wafer cost, and also is very helpful for the environment. Okay, this is from the cost aspect. Secondly, from good looking aspect, you know, we use zero bus bar. As I have said, there's less shading for the solar cell. So from the customer viewpoint, the appearance of the solar module will be more beautiful. And secondly, as I have said, the diameter of the ribbon is much smaller than before. So there's less shading, and it will look much better compared with the conventional ribbon size. So it looks much beautiful. Okay, for your question. Okay.
And Jack, last but not least, I want to ask you, you already mentioned some environmental things, but I want to finish this conversation asking you about the better environmental friendly features such as reduced silver paste use and these two products.
You mean for the environmental aspect?
Yeah, like reducing this silver paste use, as you mentioned, but going deeper.
Yeah. As I have said, that zero bus bar removed the pad points, so the silver paste weight has been reduced. So from this viewpoint, it's more cost effective and more environmental. And secondly, I have said that during the solar module assembly process, there will be no soldering step. So it means we don't need to use the soldering flux. You know, soldering flux is actually can have harmful emission because it's not it's actually harmful for the workers. So if we remove the soldering process, so it's more environmental, right? And then secondly, I have said that if we use the zero bus bar, the ribbon size can be controlled more smaller, and it can balance the strength during different process. So it means we have more potential to reduce the wafer thickness. You know, previously maybe the modules, how to say, the solar wafer thickness is around 130 micrometer. But if we use 0 busbar, maybe the wafer thickness can control within 120 or 110 micrometer. So from this viewpoint, much thinner wafer will be more environmental because wafer is, the carbon footprint is much bigger in wafer. So from this viewpoint, it's very helpful. And thirdly, you can see that there's no soldering process. So the whole process temperature can control within 150 centigrade because the lamination temperature is around 150. But the traditional soldering temperature is much higher than 150. So it's more environmental. Okay.
Well, Jack, thank you for being here today with us. It was a pleasure to talk with you about these new products in Astronergy. Thank you for being here today with us.
Thank you.